Hi everyone. What I'm talking about today is going to be very directly related to many of the talks that we've had in this symposium already today. I'm going to be looking at it from a quite different angle, I hope. The work I'm describing today was carried out by myself, Chris Burwell, Michael Ricks from the Queensland Museum, aided by Mel Laidlaw and Tracy Churchill from the Threatened Species Program, and Narelle Power from DDW Fauna. I'm speaking from Meanjin country here in Brisbane, a place of learning, creating and gathering. Always was, always will be. As I worked across a wide area, I acknowledge all the First Peoples, the traditional owners of the lands where I live, travel and particularly work. I pay respect to elders, past, present and especially emerging. We surveyed invertebrates in 2020 and 2021 as part of the Australian Government's Bushfire Recovery Package for Wildlife and Habitat, in collaboration with the Threatened Species Operations Unit from Queensland Parks and Wildlife Service and Partnerships, Department of Environment and Science, as wildfires during the summer of 2019 and 20 resulted in large areas of fire-sensitive rainforests being burnt here in Queensland, raising conservation concerns for numerous invertebrate species. A set of priority taxa were selected based on their restriction to rainforests, endemicity, and often limited dispersal abilities. We used a set of standardised methods that we had used previously in Ibisca, Queensland and other surveys. This included a 5-day trapping using Malaise traps, unbaited pitfalls, dung and mushroom baited pitfalls, as well as 2 days of trapping in 9 coloured pans per site. As there was insufficient baseline data, as we've heard today, relating the priority taxa distributions to fire exposure, we monitored the effect of fire by comparing collections in severely burnt, moderately burnt and unburnt rainforest sites across 2 localities in each of Bulburren, Lamington and Main Range National Parks. Mel Laidlaw used her skills to create potential environmental impact maps for the priority taxa prior to the surveys. That habitat modelling and fire intensity mapping from the 2019 and 20 fires was used to select prospective sites. With Mel on site, on the ground, we ground truthed the fire severity data to select those replicate plots. At Main Range National Park, we selected 3 sites at Bear Rock up on the Mount Cordeaux track and 3 sites on the Mount Mitchell track at Cunningham's Gap. At Lamington National Park, we selected 3 sites at the Ibisca Queensland 300 metre sites on Canungra Creek and 3 sites at Binnaburra. At Bulburren National Park, we selected 3 sites on Bobby Range Road and another 3 sites on Dawes Range Road. I was responsible for the Malaise traps, the half-hour sweep netting and the colour pants. There were few priority taxa collected in these methods because they mainly collect flying insects. However, I did note that the sample size clearly increased with fire severity. The Malaise traps and coloured pans were sorted to order and further taxon groups by Narelle Power. I sorted the sweep nets. When I started to look at the data that I was accumulating, I removed the colour pan data. That was because it basically was non-standardised. There had been interference by animals and we had weather impacts. It rained almost the entire time of our main range survey. For example, the image that you can see here of the coloured pan is of a bowerbird at Binnaburra. They stole the pans, they put them up vines, they buried them. We basically couldn't use the data. I sorted and counted 37 easily identified taxon groups. In other words, not everything that I could easily identify. For example, Hemiptera, which I'm not an expert on, I only counted and identified a couple of species of leafhopper. So there were over 5,700 specimens recorded, identified and counted. I combined the catches from the plots with the same level of fire intensity for each park. The number of specimens collected in sweep nets and malaise traps clearly increases with fire severity in all parks. I determined the functional group of each of the taxa I identified and counted, remembering, as we've just been told, that often immature invertebrates have a different ecosystem function than their short-lived adults. Please note that the scales for each chart are quite different, with the total number of decomposers counted exceeding 3,000, herbivores at about 630, predators over 1,600, and parasites at only about 200. The number of specimens of decomposers and herbivores collected in the sweep nets and malaise traps increased with fire severity in all the parks. However, the trends in the abundance of the predators and the parasites are much less clear, although the total numbers were highest in the severely burnt sites. But what about biodiversity? I examined the patterns of the numbers of those easily identified taxa across the parks. The number of the 37 easily identified taxa that I recorded from the sweep nets and the malaise traps was related to fire severity only in Main Range National Park and overall. In Lamington and at Bulburren, the severely burnt sites actually recorded the highest number of those taxa. Unburnt sites are dark and dense. They have a deep decomposing leaf litter layer. They have ferns and vines and a full canopy. There's not much new growth nor newly fallen trees. The invertebrates have generally a higher biodiversity but a low abundance. The rainforest is in equilibrium. In severely burnt sites, we have bright open spaces, densely weedy, as you can see, with dry, newly fallen leaf litter. There is lush, flowering, fruiting new growth and many newly fallen dead trees. The invertebrates have a lower biodiversity, but higher abundance. And the burnt rainforest tends to be very dynamic. So why is there an increase in abundance in a burnt site? There's lots of new dead wood and leaf drop, leading to an increase in decomposers and recyclers. There are lush, flowering and fruiting weeds. That leads to an increase in herbivores, frugivores and pollinators. All of those create more prey for predators and parasites that then increase. However, is this trend just an artifact? We all know that the flying insects in unburnt rainforests are probably most abundant above the canopy, and they were not collected here. Is that creating an impression of decreased abundance and biodiversity? The malaise traps and the sweep nets are also most efficient in open and well-lit habitats, such as burnt areas. That's increasing the collection and again, giving us a wrong impression of abundance and biodiversity. Flying insects also are able to move in from other areas, which is one of the reasons why they're not very good short-range endemics. And so again, that has an effect on what we perceive as the site biodiversity. Also, I'm a dipteran expert, right? Has my selection of the taxa actually biased the results? So these are trends. That's all we can really say. But what has increased in abundance? Am I detecting an increased abundance in a few species of weedy insects, such as these ones here? These were some of the very easily identified and sorted species found across the parks. The U stands for unburnt, of course, M stands for moderately burnt, S is for severely burnt, and here are our numbers of specimens collected across the parks. You can see that these three easily identified and counted taxa increased markedly in abundance with burn severity. Are the numbers of these taxa actually indicating how healthy the habitat is or unhealthy? Have we got a set of indicator species that we could be using to monitor recovery, but as they decrease in number? We had some other significant finds. We found the fourth known specimen of the fruit fly Bactrossera pulchra that was described from 3 specimens prior to 1927 from the Glasshouse Mountains. We found 1 specimen of this beautiful diffridid in a malaise from a severely burnt site at Bullburren. Thanks to Melissa Starkey and Jane Royer, that specimen has now confirmation of the species determination, thank goodness, and it has been sequenced and it is clearly distinct from all other Bactrossera. We also found 2 undescribed species of soldier flies from the genus Elosoma who have these magnificently long antennae. How they fly, I have no idea. Elosoma spur1 was collected from severely burnt sites at Bullburren and Lambkin, quite separate localities. Elosoma spur2 was already known from Tamborine, and the specimen shown here was found in a severely burnt site at Lambkin and has become the paratype for the upcoming revision of that group. Additionally, we discovered 4 specimens of the 9th species of Watkinsia that was found in both burnt and unburnt sites at Bullburren and has now been described by Peter Alsop as Watkinsia incendiala, named after the bushfires. I would like to acknowledge all my co-authors, Queensland Museum staff who helped so much in this work, Parks and Wildlife staff and rangers, the DAF Biosecurity Queensland group who helped with the fruit fly, iNaturalist Australia who provided quite a few of the images that you've seen here, and the Australian government for their bushfire recovery for wildlife and their habitat funds. Thank you.